Hey everybody, as you know, I'm going to be gone today, so this is the video that I want you to watch. You should be hopefully in your groups and ready to go, but you are all listening to this on your own. So we'll start off with our bell ringer for today. I want you to go into today's folder in Schoology, and you're going to see two PDFs in Schoology. The first one is I put the Weird Water Events packet in Schoology again today. So if you did not copy this to GoodNotes yesterday, it's there for you. Go ahead and copy that in GoodNotes now. And then you're going to see a WWE. No, it's not the Worldwide Wrestling Federation. That used to be WWE, but I don't think it is now. But anyway, WWE stands for Weird Water Events, and it's a graphic organizer. So go ahead and pause the video, copy all the PDFs that you need to into GoodNotes, and then come back and start this again. Okay, so now that you've got everything in GoodNotes, let's go ahead and get started. I want you to log on to Amplify, and we're going to be in here just for a second. You're going to be in Lesson 1, so Chapter 1, Lesson 4, and it's the Weird Water Events. Let's go ahead and do the warm-up. So the warm-up has this scenario, and I want you to think about Ellie, her friend, and a puddle. So think about what Ellie's evidence shows, and then go ahead and respond to the question. So we find out that on her way to school, Ellie sat on a bench waiting for her friend. She noticed snow all around her. Later that day, Ellie and her friend walked home and passed by the same bench. Ellie's friend said there's a puddle in front of the bench. It must have rained while we were in school creating this puzzle. Ellie disagreed. She had a different claim about how the puddle formed based on the evidence from her observations. So her evidence includes, first of all, the park was covered in snow that morning, but not in the afternoon. Secondly, Ellie didn't need her jacket on the way home because it was so warm. And thirdly, it was a sunny day. So take a second to pause the video, and I want you to write in, what do you think happened to the puddle? Or not what happened to the puddle, but do you think the puddle was formed by rain? Why or why not? Go ahead and pause the video, and then come on back when you're done. Okay, so how did you respond to the warm-up? Hopefully you noted, because of the warm temperature, the fact that there was snow, but there's no longer snow, and the sun was shining, that the puddle was not formed by rain. Rather, the snow melted. And so we had a change in phase from a solid to a liquid. Be sure to hand it in so I can read what you wrote, okay? Let's go ahead. We've got one vocabulary word I want to make sure that you guys know. We used this word yesterday quite a lot, and I'm pretty confident you understand it. But your word refute means to provide evidence that goes against a claim. Now, scientists refute claims with evidence in three different ways. First of all, sometimes evidence may be used to refute or go against a claim. So you'll have evidence, like what we can look at the three pieces of evidence that Ellie had in the afternoon against the claim that rain formed the puddle. Refuting evidence may show how an aspect of that claim is not possible. Okay, so it's not possible for it to have rained because it was a sunny day. It wasn't cloudy all day long. It was all day long. That wasn't very good grammar. All day long, it was sunny. And so it could not have rained. And then look at the third bullet. It says at some point, scientists may decide to eliminate or get rid of a claim if the refuting evidence is strong enough. However, ideas may change as new evidence is gathered. And so that's kind of what we're going to do today. We're going to gather some more evidence so that we can continue to look back at these three claims. Now, right now, yesterday, based on what we went through in the sim, we think that we have enough evidence to support claim 2, but what I really want is good evidence to refute claim 1 and claim 3. So let's see if we can find that within the using the evidence that we are going to get from reading the articles. So we're going to read a set of articles on weird water events. You will read only one article, which will help you collect evidence to either support or refute one of the form user's claims. You're going to read in groups. Each group member will read a different article. So each one of you will have one article that you're going to focus on. And then later you're going to share your evidence. And as a group, you're going to decide whether you support or refute the claim. Okay, so I'm going to demonstrate how to annotate by reading chapter 1, Weird Water. What I want you to do is I want you to, you can copy my annotations, but I really want you to pay attention. Because you guys are really focused, there's still quite a lot of you who are turning things in that are mostly highlighted, and maybe you'll have one very unscientific annotation like cool or how. It's a good start, but by this time in January, I really want your annotations to be a little bit more scientific. I want your annotations to be less about you as a 7th grade student reading an article and more about you as a student chemist trying to figure out how molecules move, okay? So as you're reading the articles, mine included chapter 1, but then later on when you read your own articles, I want you to focus on 2 kind of topics. The first one is I really want you to understand and think about what's happening at the molecular scale. And then we're going to introduce a new vocabulary term called freedom of movement. And I highlighted that in green because I'm going to demonstrate how I want you to annotate and really pull out that new phrase, freedom of movement. All right, so let's go ahead and begin. Chapter 1, Weird Water. Water is amazing stuff, and it does some amazing things. It flows, it sparkles like diamonds, and it seems to appear and disappear like magic. These are all large-scale observations. And so when I see that term large scale, I know that in class we've been talking about macro scale, so I went ahead and I wrote that next to it. These are all large-scale observations of water's appearance that we can make with the human eye. Again, macro scale, what we see with the human eye, so I underlined human eye. We can also think about water and all substances on another scale that we cannot usually see, the molecular scale. I highlighted that because that's a vocab word. Molecules are too tiny to see, but they are very important. Water is made of molecules, and so is almost everything else on Earth. The appearance of water is determined by the way the water molecules are moving. So the appearance is that large scale, macro scale. So I underlined that, and I drew my arrow back up to large scale because it's important for me to remember the way something looks is large scale. So the appearance of water, whether it's a solid, liquid, or a gas, is determined by the way the water molecules are moving. You might think of water as a liquid, but water can actually exist in 3 different phases: liquid water, solid ice, and a gas called water vapor. No matter what phase water is in, the water is still made of the same molecules. They just move differently. This is really important to remember. No matter what phase the water is in, the water is still made of the same molecules, okay? In the solid phase, now I went ahead and put a box around all the phases. So you're going to see solid, liquid, and gas phase. I put a box around that. In the solid phase, known as ice, water molecules are tightly packed and can move only in place. Remember yesterday we talked about solid molecules, molecules in a solid phase, how they vibrate. And I wanted to remind myself to really pull out that question, how do the molecules move? So I put that up at the top, and then I'm going to refer back to that. So in a solid, the water molecules vibrate. In the liquid phase, put a box around liquid phase, water molecules have greater freedom of movement. Now here's that phrase that we're picking up. This is a new vocabulary term. And so I put a green box around that. Just to really pull out that, hey, this is that new phrase I wanted you guys to really pull out. And then you'll notice next to it, I put a capital F, capital O, capital M. for right now, I don't know what freedom of movement means, although I kind of have an idea. So I put a question mark. But I want you guys to know that in the future, whenever we talk about freedom of movement, I'm going to abbreviate it FOM. So I'd like you to go ahead and somehow, like just like mine, put FOM next to it so you associate FOM with freedom of movement. They're able to move around and flow from one place to another. Okay, so there's my answer. What's freedom of movement? It's the ability for a molecule to move. Well, that totally makes sense. Yesterday, when we were looking at the sim, when we were comparing the phases, molecules in a solid phase, they really did not have very much freedom of movement. As they were moving into a liquid phase, when they would change phase from a solid to a liquid, that freedom of movement increased. That totally makes sense. And then from a liquid to a gas, the freedom of movement increased even more. So as I'm reading this, I'm thinking, okay, I remember seeing this in the sim, and let's making some predictions as I'm reading, saying, okay, I'll bet when I read down later in that next paragraph, when we talk about gas, the freedom of movement is going to be even greater. It says, however, as a liquid, they still stick together, which is why liquid water forms little beads on a car windshield when it rains. That's interesting for me. I went, that's interesting to think of. Okay. In the gas phase, known as water vapor, water molecules move around a lot and they don't stay right next to each other at all. Okay, so the freedom of movement must be increased. Water vapor doesn't stay where you put it. To learn more about some of the unusual ways water behaves in its different phases, choose one of the chapters that follow. Okay. I'm not done annotating yet. On each one of your articles, you're going to have these graphics. And it's very important to me that you spend some time looking at these graphics. Now, my graphics show the molecular scale of a gas, solid, and liquid. And I want to tie in that freedom of movement. So if I look at it, the gas it's described as free to move, so it's got greater freedom of movement. A solid can only move in place, and a liquid can move and flow around each other. So I want to think about what that means about the freedom of movement. So as you read your article, really pay attention to the graphics that are included. You may or may not have all three. You might just have two. So really pay attention. And I am going to look to see that you guys have that graphic annotated as well. Okay? All right. So now it's your turn. As a group, go ahead and decide who's reading which article. Make sure everyone reads at least one article. Now, if you're in a group that does not have 4 people in your group, you may have to read one or more articles together. So just take turns reading out loud and annotating together. When you're finished reading and annotating, take turns summarizing and sharing your annotations. Remember, go in order. So whoever read chapter 2, you go first, and then chapter 3, chapter 4, chapter 5. And as you're talking about your chapter, just kind of summarize what your chapter was about. And talk to your partners about your annotations. If you did not read the article, you're going to copy your partner's annotations. So we're kind of helping each other out. So don't skimp with the annotations. You're not going to help each other out by doing that. Once you're finished summarizing and sharing your annotations and talking about the different articles, then you're going to go ahead and fill out the WWE graphic organizer together. And then submit that graphic organizer to the WWE graphic organizer assignment in Schoology. Now, I'm hoping that this takes the entire class period. If it doesn't, and some of you guys are going to work a little bit faster, and that's okay. If you still have class time, you can go ahead and work on other homework, read, or if you want to study your vocab words, you can. All right? Let me know if you have any questions. I will be back around 12:30 today, and I'll see you guys this afternoon, okay? Be good. Talk to you later.